up so you can see me. Yeah. So I've got a little problem. This is my box of hydroelectric stuff, kind of. I've been looking for this. Okay, that should go in there. This is a spear valve. It's a special type of valve that, let's get this out of the way. Pull these out first since I need them. This is a spear valve. I got this on eBay from a guy in, I think, Turkey or Italy. I'm not sure. What this is it allows you to adjust the spear inside, in and out of this orifice. You see that? So it's going out, and that's closing off the hole. And then I crank it back, it retracts in, and it opens up. What's special about these is it allows you to adjust the volume of flow while maintaining 100% velocity. Most, like hose spigots, you pull it on halfway and you get half velocity because it's the same orifice diameter but half the water, so you get half the velocity. This, you change the orifice diameter so you get half of the water but the same velocity. A little bit expensive, a little bit different. Let me go get two other things that are relevant. I'll show you. Are they in here? Well, there's one, there's the other. Okay, they are in here. Lucky me, I don't have to go anywhere. These are, let me zoom in a little bit so you can see a little bit better. These are also variable orifice nozzles of sorts. I guess we'll start with this one. This is an electrical gland fitting. You saw this in one of the previous videos where, let me take this off. It's a rubber ring inside that gets scrunched down to a smaller diameter. So it's open, you crank it down, and it closes down to a smaller nozzle size. Yeah, it works, but if you take a close look at that, that is not a smooth hole. So that would not be an efficient nozzle geometry. So this is the cheap way that it's done. You can look on eBay. I've seen a guy who actually uses these to build and sell nozzles. I don't think that's necessarily the best option. This is another version that I found at Lowe's. It has 3 ball bearings there and a flexible inner core. You screw this down and it pushes the ball bearings in against that core. So you can close it all the way off and you can get a very small jet and a jet that's the full orifice diameter as an option. This would work probably if you stay in the like top, I don't know, 50% of jet diameter, because it has goofy geometry when it closes off. And you get a jet of water that's a triangle, and that's not necessarily the most efficient either. And this is a fairly big nozzle, but it's you can't find anything smaller. None are available commercially, probably because it's not economical at that size turbine. For most people, not like my case where I have very high pressures, and a small nozzle will still generate lots of power. The problem I have with this, the threaded fitting that's on here, the seller says it's a BSP thread. British standard, it's British standard pipe thread. And it comes in 2 different variations, tapered and parallel, just like National Pipe thread. National Pipe thread can come in parallel and tapered as well. This thread I haven't even actually looked myself, so I don't know what it is. But if we look at it, oh, come on, Joe, figure it out. Sorry, it's a little bit goofy geometry to figure out what it's doing on the camera. This thread is parallel. So that's not a big deal. You just have to use a parallel. You can use a parallel thread in a tapered fitting. This is a tapered fitting. This is a 2-inch sanitary fitting. So that's a 2-inch ID, and it has a gasket here and a V-band clamp that goes around. It's also called a tri-wing fitting, but a tri-wing or a tri-clamp fitting is more of a brand name. As a tri-clamp, it's a tri-clover clamp. So people usually will call these tri-clamp fittings or sanitary fittings, but tri-clamp is a brand name. Anyways, I like this method of fitting because you can get all sorts of different, adapter ends here. Zoom down here a little bit. That's easier for me. I don't have to hold it up in the air. So on the opposite end of the sanitary fitting, you can get all sorts of different ends. For example, my initial intention was to put this on here and then just made it up with a barb fitting, and that would go to the rest of the control manifold, I guess you could call it, or mechanism, or branching, control branch, who knows. I don't have a name for it yet. And you can get different sizes. So most of my fittings that I'm using are actually 1.5 inches, which is this. But you can't get an 1.5 inch female thread with an 1.5 inch sanitary. So I had to kind of effectively use this as an adapter. But this isn't going to work. I think because my problem isn't with this. Not really. It's that this, I think, is a national pipe thread that they sent me, but I ordered a BSP thread. This does not thread on. It goes on. Let me put it up here. It kind of starts, and you get about half a turn on it if you can get it lined up right. And it doesn't really line up easy either. So this, unfortunately, isn't going to work. I might have to return this and maybe get another one. I'm pretty sure that this is a national pipe thread because here's a standard national pipe thread fitting, and come on, line up. This threads in just fine. So I think this is actually a 1.5 inch NPT instead of the BSP. You can see the difference here. The threads don't really line up. There we go. The threads don't line up. You can see that it's about a full thread off over this inch. What I'm going to end up doing here is thread on this union and then thread this into the union. And then there's my 1.5 inch adaptation, so then I can go back to 1.5 inch for everything else with these guys. So I'm going to put this together and hook it up to the penstock, and we'll see what it does. I have a heat gun, but the pipe that I'm using with this, I don't want to burninate, or just burn or char or change the color. And a heat gun will very easily do that, but a hairdryer will not. So I'm going to try putting one of these fittings on this. This video is getting long enough that I was going to do it as just like a little non-numbered part of the series, but I think it'll be long enough to be a actual numbered part of the series. But at the same time, it may also have enough independent views because of the thumbnail that I will have used that people will come in and say, what the heck is this project? I think this will get me the cleanest cut. It's what we used in the hardware store on the other end. This end was kind of mangled. Somebody had used a PVC saw on it. There, she's going through. Fortunately, it's not deep enough. I can just barely cut my penstock with this cutter. Try to line up the end. Clean cut. That's pretty good. All right, let's heat it up. It's pretty good. My cut was apparently not quite square, but I had to heat this up because the fitting here is meant for a pipe that's 1.6 inches in diameter inside, but this is 1.5 inches ID. So it had to stretch a full, what would that be, 100 thousandths to fit over that. That's why I heated it up. Get my fingers out of there so I don't stab myself with a screwdriver. Alright, that's pretty good. Part of the reason for doing this video is because this pipe is what was at the end of the spool. See if I can get an end-on profile there. And it's not flat, and it's really hard to wrestle with. Anyways. I'm curious what this will do when I put it under 120 psi of pressure. If it'll stretch out into a long solid snake, or if it will want to retain this shape. And if it wants to retain the shape, then I'll leave it pressurized and let it sit for a while, and it'll probably straighten out. I got a good deal on this. I only asked for 10 feet, but he gave me like probably 18 feet, 16 feet of pipe, because it was the end of the spool and it was just hard to pull off and measure. Now, this end, I'm going to use one of these fittings. This is 1.5 inches to go to the rest of the control hardware that I have. And it's actually 1.5 inches to fit in the 1.5 inch hole. So it'll probably go in pretty easy once I can smush this down. Okay, that'll have to work. The clamp needs a little bit of room to fit around here. Hopefully I left enough. I think I'll just cut this off anyways. This little bit here. Put this right over the middle of the barbs. Okay, now let's see what it does. All right, here we are on the yard. I'm gonna hook this up and see what happens. I got a little bit of mud on stuff, so I have to rinse it off, like my hand and the fitting and the seal. Okay. Okay. I think it's just going to stay in a loop. What do you think? Leave a comment, but that's kind of redundant because I'm going to figure it out right now. All right, we've got a small leak here. and one here at the nozzle. And it's no longer flat, but it's still coiled up. I guess now we'll see how well this nozzle really works. Ow! Ah. It's shooting pretty far. Let me see if I can back you up and get some perspective here. Something like this. Except we'll have to level the tripod. Yeah, that's better. Okay, that was shooting from here. I'm going to count out my paces and get back to you. .38. I'd say it was, that I could see of the bigger jet, it was ending here 38 paces away. 38 times 3, that's 93 times 8, 24, 114 feet away that jet was spraying. So that's pretty impressive. So the seller of this said that it's good down to about 2 liters per second, and the maximum that my spring can output is about 4 liters per second. So this will only be useful for the top end of the flow, and for the rest of it I'm going to have to use fixed nozzles or some other thing that I haven't devised yet. I guess I can turn this on slowly so you guys can see the jet formation. You see it starts on one side, and we got it wet. Let's try this again. A little further away to begin with, because it's splashy. Every time I turn the jet a little bit, it pushes back more. It's thrust. That's about a finger diameter. And debris, and debris's gone, and there's more debris, and it's gone. Okay. Well, that was certainly entertaining, if not a little bit successful. I cleaned it up a little bit. We'll try to get a thumbnail picture. Now, how does it work for leaf blowing? Next up on my list of things to do is build a turbine housing. So I got this welder. I have other content that I'll have to release at a later time once I get enough welding content to put up a full video. And I went over to my neighbors because I was looking for some like welding coupons or stuff to just practice welding. So I got some pieces of stainless here, and some angle iron and some mild steel, all thread. Not that I'm welding on all thread, it's just good to have around. Aluminum, and a bunch of plastic here. And he also gave me this. It's 120 wall, 316 stainless steel, so that will be the turbine housing. He also gave me enough UHMW on his scrap plastics pallet because he's thrown out a whole bunch of plastics, like machine shop grade plastics. So I have enough UHMW to last quite a while. Here's a sheet of it. There's a little bit of a thinner piece there for glide pads for my table saw, and some other pieces there. So these will work good for fence facing material on my table saw, which is fantastic. Thanks, Joe. You're awesome. So that's the end of this video. Wasn't really expecting to make a video like this, but here we are at the end of it, and I think it's going well. And I have some gifts that were bought for me from my Amazon wish list, so that'll be a separate video. I'm trying to keep this video on point, and I'll see you guys around. Like, comment, subscribe. Goodbye.